At Onshape, we've had the unique opportunity to look at how engineers use old CAD systems and solve key problems they experience with core CAD features that they use every day. We call these fundamental improvements Parametric Modeling 2.0. So not only do we have the modeling features that you need to do your job, but in Onshape, they're better. There are 5 examples that I think are a good representation of Onshape's better core CAD functionality. They are sheet metal, configurations, standard fasteners, multi-part design, and in-context assembly editing. The first example is sheet metal. Sheet metal in old CAD systems has always been a struggle, with a lot of back and forth between the folded and flat state of the model. It was very much a trial and error process where you would make changes in the folded state and then go to the flattened state to see if those changes caused issues with the flat pattern. With Onshape, this is solved with our simultaneous sheet metal tools. In Onshape, you can view your part in the folded state, the flat state, and as a table view all at once. Any changes made in any of those 3 places is automatically reflected everywhere else. So you can make changes to your folded sheet metal part and instantly know if that's going to cause an issue in the flat. In fact, Onshape will even notify you when you have collisions in the flat. Another example is configurations. Configurations in old CAD systems has traditionally involved building large tables for every possible combination of your design. This is not only time-consuming, but error-prone, as it often involves a lot of copying and pasting of values. And in highly configurable designs with thousands of combinations, this is simply not practical. To solve this in Onshape, we allow the engineer to have multiple independent inputs to create configurations. This gives you a potentially infinite number of configurations that you can create on the fly as you need. A handful of independent inputs in Onshape can replace a table with thousands of rows in old CAD systems. The next example is standard fasteners. Dealing with standard fasteners like nuts, bolts, screws, and washers has always been a struggle in old CAD systems. To start, old CAD systems often required a special license or add-on to access their library of standard fasteners, meaning you'll need to buy a more expensive version of the software to insert nuts and bolts. It's also difficult to use. Simple things like inserting a washer into the bolt stack is hard to do, and often requires you to delete everything and start over. But the biggest problem with old CAD systems and standard fastener libraries is the file-based nature of them. Each engineer in the company essentially has a separate, complete copy of all the files in the standard fastener library. So a change made in one fastener library can cause the fasteners to fail to load when anyone else opens the assembly. With standard content in Onshape, no special licensing or add-ons are required. Simply click Insert in the assembly and you'll see the option for standard content. Inserting standard content is easy. You can choose the details of your fastener from a list, or use the auto-size function to let Onshape find the right fastener for you. Every piece of standard content in Onshape has a built-in mate connector, so you can insert your fastener and mate it into place with a single click. If you want to insert multiple pieces of standard content at once, simply click a face and Onshape will populate all holes in that face. Inserting washers or nuts into the stack is just as easy. I can specify the details of my washer or nut, select the face where I want to insert the washer or nut, and choose either to insert closest to or furthest from that selection. Onshape will automatically shift previously inserted pieces of standard content to accommodate. No need to delete and reinsert. One final thing to mention about standard content in Onshape is everyone in your company using standard content is using the same parts with the same metadata. In fact, if you edit the part number and description for a piece of standard content, that change will automatically be reflected throughout your company. Next up is multi-part design. Many old CAD systems have what's called a multi-body approach to top-down design in a single part. Take an example like this concrete bucket designed in an old CAD system. Here you can see we have 41 separate bodies for each of the parts in this concrete bucket. The problem is inserting these 41 bodies into the assembly. In old CAD systems, you can't insert these bodies directly into the assembly. Each one must first be saved as a separate part file. So in our example, I must first create 41 separate part files, and then those individual part files can be inserted into the assembly. So we had one file with dozens of bodies. Each body had to be saved separately, generating dozens of files, all so that we can simply insert this design into the assembly. This workflow is tedious, confusing, and has a huge potential for error. This is a problem Onshape has solved with the Multipart Part Studio. In Onshape, you can design multiple parts together in a single Part Studio environment. And with Onshape, these are real parts from the very beginning, meaning they can be inserted into the assembly and drawings no differently than any other parts. And they can have metadata like part number, description, revision, and other properties assigned to them like any other parts. So in our example, I can insert the same concrete bucket into an assembly with a single click. No intermediate steps necessary. And most importantly, if I want to change my concrete bucket design in the Part Studio, it will automatically update in the assembly. The final example is designing in the context of an assembly. In old CAD systems, designing in context of an assembly has always been a fragile process. Simple things like moving parts, or renaming or moving a file, would cause a domino effect of errors and unintended consequences when the model was rebuilt at random times. It was so notoriously unstable that many companies either banned the practice or required references to be broken before design could be released. With Onshape, we saw a unique opportunity and created our managed, in-context design tools with these problems in mind. In Onshape, when you design in context, we take a snapshot of the assembly at that moment and bring that into the Part Studio so that you can work around it. With Onshape, you manage when updates happen, so you're never surprised with random rebuilds that cause your design to update in weird ways or fail to update altogether. These are just a few of the examples of the ways that Onshape has improved the core CAD experience for the engineer, saving you time with tools that are easier to use and more robust, allowing you to focus on what you do best.